Good morning, dear students. Yesterday we have seen the vectors and how to draw the vectors in standard position. We have seen how to draw initial point, terminal point in vectors in standard position. Now there are some new words here: direction, magnitude, quadrant bearing, true bearing, parallel vectors, equivalent vectors, opposite vectors, resultant vector, triangle method of addition, and parallelogram method of adding the vectors. So in your operations with vectors, you will need to be familiar with the following vector types. Parallel vector have the same or opposite direction but not necessarily the same magnitude. Like you can see here, vector A and vector B are parallel, so they are not having the same magnitude, while vector A is also parallel to vector C, but they are in opposite directions. So you can see that A and C in this case both have the same magnitude, means same length they have, while A is equal to C and A is not equal to B, because A is lengthier than B. Now, if you can see here, A is going in this direction while the B is in other directions, and they are equal vectors, so A equals to negative B. Triangle method, tip to tail. To find the resultant of A and B, follow these steps. Like you can see, this vector is A and this vector is B. Translate B so that the tail of B touches the tip of A. It means that you join these two vectors, the tip of A and the tail of B joined together. Then the resultant would be A plus B. So then you can draw the resultant here. So this is called head to tail rule. The resultant is the vector from the tail to A to the tip of B. To find the resultant of AB, follow these steps. So the step 1, translate B so that the tail of B touches the tail of A. Now you can see the directions here. So this one, you join it over here, so it looks like this way. Now step 2, complete the parallelogram that has A and B as two of its sides. So this is A, this is B, and this is the resultant A plus B. So this is called parallelogram method, tail to tail. This is triangle is tip to tail, while parallelogram method is tail to tail. Some real life examples are here. Find the resultant of two vectors. While hiking in the woods, Shelley walks 2 kilometers north, 30 west from her camp, and then walks 2 kilometers directly east. How far and at what quadrant bearing is Shelley from her camp? So let P equals to walking 2 kilometers north, 30 west, and Q is walking 2 kilometers due east. Draw a diagram to represent P and Q using a scale of 1 centimeter to 1 kilometer. So you can see this is the P, so this is the north, and you have to go counterclockwise towards the west 30 degrees from the north. And this is the Q, this is due east. It means that straight O to E direction. Now use the ruler and protractor to draw a 2 centimeter arrow 30 west up north to represent P, and a 2 centimeter arrow due east to represent Q. So these are the two vectors. You can make north 30 here on in the side of west, and this is the due east 2 centimeter. Method first, we are doing it with the triangle method of addition. Translate Q so that its tail touches the tip of P, then draw the resultant P plus Q. So in the previous diagrams, the Q was going to east direction, so you just translate it and put its tail with the head of the vector P, and then from this tail to this head is your resultant vector, which is P plus Q. The second method is parallelogram method. In this method, translate Q so that its tail touches the tail of P. Before its tail was touching the tip of P, but now the tail is touching the tail of P. Then complete the parallelogram and draw the diagonal resultant P plus Q as shown. So this and this should do here, and then make this resultant, so this would be P plus Q. This is the other method. So again, with the both methods, you get the resultant vector is P plus Q. Both method produces the same resultant vector P plus Q. Measure the length of P plus Q and then measure the angle this vector makes with the north-south line as shown. The vector length 2 cm represents 2 kilometers. Therefore, Shelley is 2 km at the bearing of 30 east of north or north 30 east from her starting position. So this is the resultant vector you can see in this diagram. So answer is 2 km north 30 east. So this is a guided practice for you. In an orienteering camp, Miguel walks north 80° east for 150 feet and then walks 200 feet due east. How far and what quadrant bearing is Miguel from his starting position? Okay, so one of this would be the answer. So A is the answer. This you can get by making the diagram like you did in the previous example. So here is some guided practice 3A, 3B, page 485 for you, and then exercise 8.1, page 488, questions 13 to 17 odd, and 22, 23, 24. Have a good day. Try to practice all these questions and send me the answers for correction. Thank you very much.